Hi, it's Alan from Crashtest Security. In this video, I will tell you more about frame injection attacks, how they work, and what you can do to prevent them. So let's get started. As a general category, frame injection attacks, sometimes called framing attacks, denote the strategy of injecting frames into websites for various malicious purposes. These include using the frames to fool users into revealing their credentials, running a script on a user's browser, redirecting users to malicious websites to perform a phishing attack, etc. Frame injection attacks are listed under the OWASP Top 10 2021 injection category. Though compared to other types of injection attacks, they pose a lesser threat. However, given the right circumstances, a frame injection can also execute a clickjacking attack, cross-site scripting, request forgery, frame hijacking, etc. Cross-frame scripting, also known as a frame injection, is one instance of a framing attack. It eavesdrops on users' actions by loading a legitimate third-party page in a frame that runs a malicious script. This is then used to leak keyboard events and other browser events, and capture user input, such as login credentials. i.e., it is a form of phishing through frames. Typically, since the same origin policy is part of all modern browsers, conducting an XFS should be impossible. The SOP prevents one origin from reading and accessing content from another origin. This means that a website hosting a frame that loads another website should not be able to read and record the frame's contents. However, old versions of some browsers with a buggy SOP implementation make it possible for events to be leaked across frames, which creates the possibility of executing a cross-frame scripting attack. This type of attack is very closely related to the clickjacking attack, since both use a similar approach, though to a different effect. For an XFS to be possible, the following conditions must be met. The attacker must target a legitimate website that controls user input, such as a login page. And that website must allow being embedded in an iframe. The attacker must control a website on which they host the iframe that will load the legitimate website along with JavaScript code, which they will use to capture user-initiated events. A user must have a browser with a faulty SOP implementation that allows for events to be leaked across frame sets. The attacker must successfully lure the user to the website under their control via social engineering and trick them into performing actions that can be recorded, such as logging into the embedded website. If these conditions are in place, a cross-frame scripting attack may succeed. For this purpose, an attacker will position a frame on a page they control, fakewebsite.com, that will display a legitimate website, realwebsite.com. They will expand the frame to fill the whole page and hide its borders so that it cannot be distinguished from realwebsite.com. The attacker will also set up a JavaScript code on fakewebsite.com to listen to user events and record these, which is possible due to the faulty SOP implementation. As a result, when a user attempts to log in at realwebsite.com, their actions will be recorded, and their credentials will be captured. Other uses of XFS. Cross-frame scripting can potentially also launch cross-site scripting attacks. Given a buggy SOP implementation, if the targeted website embedded in the frame is also vulnerable to a cross-site scripting attack, XFS can be used to that end. This would allow attackers to do more than just eavesdrop, inject malicious code, steal cookies, and then hijack sessions. Technically, there is no significant difference between launching a regular XSS or an XSS through XFS. Conducting cross-site scripting through a frame may be more stealthy, but its effects are the same. The element of greater secrecy is achieved by loading the legitimate website in a frame and then hiding the frame. When the user visits the attacker's website, the frame will load the other website along, and the cross-site scripting attack will be performed entirely without the user's knowledge. Cross-frame scripting vulnerabilities are due to faulty same-origin implementations and browser bugs. For this reason, developers are not to blame for instances of XFS. However, this does not mean that there is no cross-frame scripting fix that you can implement. Given how similar cross-frame scripting and clickjacking attacks are, some measures you can take are the same as when preventing clickjacking. Here's what you can do to stop or reduce instances of XFS and other frame injection attacks. Use the content security policy to whitelist valid frame sources specifically. This can be achieved through the frame SRC, child SRC, or frame ancestors directives that allow you to control framing behavior and sources. Use the XFrame options header to specify whether a page can be rendered in a frame or not. Consider including this header automatically on every page. In addition, attackers can inject frames via a URL containing JavaScript by exploiting cross-site scripting vulnerabilities. To prevent this, You should also block user input in URLs where possible. Define a list of accepted URLs. If you need to use dynamic URLs, only accept URLs that come from whitelisted domains. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.